Hello everyone, myself Professor Rutuja Jadhav, Assistant Professor of Computer Engineering Department of Kekewag Institute of Engineering Education and Research, Nasik. Today we will be discussing a topic called Splay Trees. So let us begin. This is the outline of today's lecture. First we will see the introduction to Splay Trees. Then we will discuss different Splay tree rotations. Then we will discuss how to perform insert operation on the Splay tree. And finally, how to perform delete operation on the Splay trees. So these are the objectives of the today's session. First, to understand the concept of Splay trees. Second, to understand various rotations that can be performed on Splay trees. Third, to understand how to perform search operation. Fourth, to understand how to perform insert operation. And fifth, to understand how to perform delete operation on the Splay tree. Outcomes of the session. After finishing the session, you will become familiar with the Splay trees. Second, you will be able to perform search operation using various rotations. Third, you will be able to perform insert operation using various rotations. Fourth, you will be able to perform delete operation using various rotations. So let us begin with the introduction of the Splay tree. So Splay tree is a binary search tree with additional property of self-balancing. In this, the recently accessed element can be accessed quickly as it becomes the root node or it is nearer to the root node. Basic operations like search, insert and delete can be performed in log n time. All above operations are combined with one basic operation called splaying, which means rearranging all the elements in the tree so that splayed element is placed at the root of the tree. Just like we have different rotations in ABL tree, here also we have 6 different rotations. Before discussing it, let us see the important nodes that are involved in the rotation. So there are 3 nodes. First is the recently accessed node that is represented as X. Parent of X represented as P. Grandparent of X represented as G. So there are 6 cases, or you can say 6 rotations that can be performed on Splay trees. First, zig step. Next is zigzag step. Third is zig step. Fourth is zag-zig step. Fifth is zag step. And the sixth one is zag-zag step. For better understanding, just remember zig means left and zag means right. So let us understand the rotations in detail. So first is zig rotation. So zig rotation is similar to the single right rotation in the AVL tree. That means every node is moved one position right from its current position. Let us see the example. Suppose in the tree given below, you want to perform splay operation on node 3. So in order to bring the node 3 in the root node, you will have to perform one single right rotation. That is a single zig rotation and 3 will become the root node. Remaining other elements will be rearranged as per the properties of binary search tree. So zig rotation means one single right rotation. Next rotation is zag rotation. It is the opposite of zig rotation. So zag rotation means it is similar to the single left rotation in AVL tree. So every node is moved one position to the left from its current position. Suppose in the given figure we want to splay node 5. So in order to bring node 5 into the root node, you will have to perform one single left rotation. That is one single zag rotation. And node 5 will be in the root node. All other elements will be rearranged using the binary search tree property. Next is zig-zig rotation. So we have already discussed zig rotation. Zig rotation is one single right rotation. So zig-zig can be a series of 2 right rotations. So consider the example. If you want to splay node 2. So in order to bring the node 2 into the root node, you have to perform a series of 2 right rotations. So that 2 will become the root node. And other elements as usual will be rearranged using binary search tree property. Next is zag-zag rotation. So it is opposite of zig-zig. So zigzag was a series of 2 right rotations. Then zigzag is nothing but series of 2 left rotations. So let us see the example. Suppose we want to splay the node 6. So in order to bring the node 6 into the root position, you will have to perform 2 left rotations. After performing 2 left rotations, you will get the tree shown below. And as usual, the other elements will be rearranged as per the properties of binary search tree. Let us move ahead. Now the next type of rotation is zigzag rotation. In zigzag rotation, there is a sequence of rotations followed. Here we are performing first one right rotation followed by one left rotation. So let us see the example. So here, suppose we want to splay 4. So in order to bring 4 into the root node, you will have to perform series of operations. First, you will have to perform one right rotation. That is, you will have to perform first zig rotation. Once you perform one right rotation, you will get the intermediate tree as shown in the middle figure. And then you will have to perform one left rotation. That is, you will have to perform one zag rotation in order to bring node 4 into the root position. So this is zigzag rotation, which is a series of one right rotation followed by one left rotation. Next is zag-zig rotation. It is opposite of zigzag. So here you will have to first rotate left and then rotate to the right. So it is a series of one left rotation followed by one right rotation. So let us see the example. Suppose in the figure in the tree we have to splay node 4. So in order to bring node 4 into the root node, you will have to perform 2 operations. First you will have to perform one left rotation, that is nothing but the zag rotation. After performing zag rotation, you will get the intermediate tree shown in the figure below. And then you will have to perform one right rotation in order to bring it into the root node. So if you perform one right rotation, that is you are performing a zig rotation. So after performing zig rotation, you will get the tree as shown in the figure. So zag-zig rotation is nothing but a sequence of one left rotation followed by one right rotation. So these are the 6 different rotations that can be used in order to perform search, insert, delete operation in the Splay trees. So let us discuss about the insertion operation in Splay tree. So step 1, check whether the tree is empty. Step 2, if tree is empty, then insert the new node as the root node and exit from the operation. Step 3, if tree is not empty, then insert the new node as leaf node using binary search tree insertion logic. That is, if the element is lesser than the root node will be placed in the left subtree. If the element is greater than the root node will be placed in the right subtree. Step 4, after insertion, you have to splay the new node. That is, you will have to bring the newly inserted node into the root node using various rotations that we have studied. So let us see the example of insertion operation. So initially we are inserting a node 1. Because the tree was empty, this is the root node. Next, suppose we want to insert node 2. Because 2 is greater than 1, will be placed in the right subtree. Now we will have to splay the node 2. That is, we will have to bring the node 2 in the root position. So how we will bring that? So we will have to perform one left rotation. That is, we will have to perform one zag rotation. And then you will get the tree as like this. Now let us insert node 3 in the tree. Again, 3 is greater than 2. So it will be placed in the right subtree. Now splay 3. So again, you will have to make 3 as the root node. So you will have to perform one left rotation. So after performing one left rotation, this is the tree you will get. That is the zag rotation. Again, suppose we want to insert node 4. So again 4 is greater than 3. So it will be placed in the right subtree. Splay 4. So again you will have to bring node 4 into the root node. So perform one left rotation, that is one zag rotation. So this is the left skewed tree you will be getting after a series of zag rotations. Now pause the video and solve the exercise given below. You have to insert node 80 in the given tree. So what logic you will be following? What steps you will be following? You have to insert as per the BST logic and then finally splay it. That is, try to bring it into the root node. So this is the solution for exercise 1. Hope you have understood the insertion operation. Now let us proceed for the deletion operation. Deletion operation in Splay tree is similar to deletion operation in binary search tree. But before deleting the element, we first need to splay that element and then delete it from the root position. Finally, join the remaining tree using binary search tree logic. Let us see the example. So this is the tree given, and suppose we want to delete node 8. So first you will have to search the node 8. Okay, because it is lesser than 10, we will be searching in the left subtree. Because it is greater than 5, so it is present on the right side of the 5. So we have got node 8. Now we need to delete it. So we need to splay it first. So perform one splay operation. That is, you will have to perform one left rotation followed by one right rotation. That is, perform zigzag rotation, and the node will be the root node. Now delete that node. Once the node is deleted, you will be getting two subtrees, left subtree and the right subtree. Now find the largest element from the left subtree, splay it, and then connect the tree. So that is the deletion operation in the splay trees. Pause your video and perform the exercise 2. That is, you have to delete node 30 from the given tree. So you'll have to first search the node 30, splay it, bring it into the root node, delete it, and then join the two subtrees. Solution for exercise 2 is shown on the figure. So hope you have understood the concept of splay trees and the various rotations involved in splay trees and the insertion and deletion operation in the splay trees. So purposely I have not included the search operation in the splay tree because in deletion operation you have to search the node and then splay it. That is nothing but the search operation. So this is the summary of the session. We have discussed the concept of splay trees. We have discussed 6 different rotations: zig rotation, zag rotation, zig rotation, zag rotation, zigzag rotation, and zig rotation. Then we have studied the insertion operation in the splay tree and the deletion operation in the splay trees. Now you can attempt the quiz which I have displayed in the URL below. This is the quiz using Google Forms. So for your self-assessment, you can attempt the quiz. That is it for the today's session. Thank you.